All right, guys, this is quick. I know this angle on this video is less than ideal, but I figured you might want to see me as I'm writing about this. So we started talking about acids and bases, and I know that you've been watching videos that haven't been me, and I'm sorry. I have 2 young kids, and so getting a few minutes to myself to actually record these has been difficult. So, but I wanted to talk to you about titration, and when I talked to you about titration, I wanted to do it myself because it was really important to me that you understand where the purpose and why this thing is important. Like, we're learning remotely, Mrs. Bell. Why should I care about titration and acids and bases? Well, I think acids and bases are important, and hopefully you took a chance, spent some time doing that. There we go, titration. Hopefully you spent some time doing the pH thing that I had you figure out, and you can see like a lot of the things around our house are actually acids and bases. Have pHs that are higher than 7, which makes it a base, or have pHs that are lower than 7, which make it an acid. Now, titration is what happens when you mix an acid and a base, okay? So what happens in a titration is what we call a neutralization reaction. So you have an acid plus a base, and what happens is it neutralizes. So the acid goes away and the base goes away, and you get a salt and water. Salts generally do not change your pH. So your super low pH starts to come up, and your high pH starts to go down. And ultimately, in our cases, they meet in the middle if you do it precisely, at a nice pH of 7, which we know is neutral. Okay, so titration is when we use those burettes, which we used in the beginning of the year during the balance in the burette lab. And I'm not sure if you remember that because it seems like it was forever ago, but that's fine because it was. So the balance in the burette lab, we use these burettes. Now, a burette is a long, skinny piece of lab equipment. I am a terrible artist. Haven't you missed it? Okay, there's your ring stand, and there's your burette, and usually there's a flask under the burette, okay? In the burette, we put something that we know, like base. Usually base is in the burette because the B goes with the B, and I don't like you guys to get confused. So we put base in the burette, and the base is sodium hydroxide in this case. And generally, we're going to use that. This is a good base. You know it's a base because you've got this OH right here. Okay, that's what tells you that, hey, this is a base. You put your base in the burette, and you know its concentration. So you learned a little bit about concentration from some of these videos. Concentration is just how many moles of base are in a given liter. So let's say that we have a concentration of 0.1 molar of that NaOH. Okay. That's what's in my burette, okay? And then in my flask down here, as you might guess, is my acid. And usually we don't know the concentration of the acid. So the concentration of our acid, let's say it's HCl, these are the ones we're going to focus on, okay, is my acid. And I don't know what its concentration is, okay? But basically, I can figure out what its concentration is if I know how much base it takes, okay? How much base reacts with the acid. I spelled it wrong. I know, Will, that you have so missed my... There we go. Let's put this guy back on. Okay. All right, guys, I can't say that I know exactly what I'm doing, but it is what it is. So I know, Will, that you have missed my amazing handwriting. This is fine. So we are going to try and react to the acid and the base so that right when the acid runs out, oops, that's when I stop using my base, okay? So I'm going to stop using base as soon as that acid runs out. Now, how am I going to know that? Well, one way we could do it is use a pH meter. A pH meter would measure the amount of the pH, and once it hits 7, I could stop. But pH meters are expensive, and what's really cheap is an indicator. And I think Mr. G talked to you a little bit about indicators in the previous video, okay? So an indicator changes colors based on the pH. The indicator that we use is phenolphthalein. And what happens is that when the pH gets to 7-ish, okay, it starts to turn pink. So here's what you're going to do. If you were in class, you would do this, and you would take all your patients, and it would be really fun. You are going to put your base in the burette, and you're going to put a certain amount of acid in the flask, okay? So let's say maybe that it's 25 milliliters of your acid in that flask. And what you're going to do is you're going to add base until it turns slightly pink. Because what happens? How do you know? What does it mean when it turns slightly pink? It means that your pH is a little bit over 7. That's what's happening with your phenolphthalein. Your phenolphthalein is going to turn pink when your pH is over 7, and that's when you know to stop adding your base, okay? You stop adding your base, figure out how much base you added, and you can calculate that. Move me over there now, okay? I'm going to give you a new formula, okay? And it's not a hard formula at all. It's a titration formula, and it's the molarity of the acid, which is the concentration, times the volume of the acid, which is the amount, okay, the size, how much volume, equals the molarity of the base times the volume of the base, okay? Essentially what we're saying here is that your moles of acid have to equal your moles of base. Look at that, okay? So in the case above, okay, I'm going to give you a simulation where you can practice this. But in the case above, here's what you've got to do. Your molarity of the acid is what you don't know, so I'm going to make that X. The volume of the acid is your 25 milliliters. The molarity of the base is 0.1. That's what I told you above. It could be whatever's given to you. And the volume of the base is the difference in your burette. So let's say that the volume of your base here is 17.6 milliliters. Okay. Now, if you go too far, you've got to start all over again. And you'll know that you went too far because you turn it really, really pink. And if you were in my class, I'd say you killed the patient. Okay. This angle is so unflattering, guys. I look a lot... quarantine hasn't been this terrible to me, okay? Let me do the math in my calculator here. All right, so I've got 0.1 times 17.6, and then I divide that by 25, and I get that my molarity of my acid is 0.0704. Molar is our units on that, okay? For these types of problems, you'll always be given 3 of them. You'll be given 2 volumes and a molarity, or 2 molarities and a volume. Almost always you'll be solving for the molarity of either the acid or the base, because volumes are very easy to measure in lab, okay? Hopefully this is helpful. I'm going to give you the titration simulation. I'm going to give you specific directions on Canvas on how to do that. You're going to need to do it 3 times successfully. That means 3 times without ruining the, without going too far, without turning it too pink, okay? And you're going to do the math and take a picture and upload it to Canvas for me. So I'll show you how to, I will post that on Canvas. Hopefully this is helpful. I miss you all so, so much. If you need anything, please let me know, okay? Bye, guys. Amazing handwriting. Oh, what did I do? Give you a new formula.